I am Ibironke Regina, and I will be presenting my work, which is implementation of ISO 19650 based framework for asset management in logistics centers for a major food retailer here in Portugal, which is Sony AMC. All right, a brief introduction. This project is looking at the implementing ISO 19650 for the asset management industry. And I think some of us are familiar with the asset management industry and the construction industry, which is the AEC industry. And we are aware of the gap between these two industries. And we know that the traditional methods have the asset management team coming in quite late during the project, or sometimes they come totally after the project. But this research is looking at how do we have an asset management team that uses the BIM information, that takes advantage of all the information and takes advantage of all the information management according to ISO 19650. So looking at the brief projection on this graph, we moved from the traditional asset management route, which is do the construction, be done with the project, deliver everything to the asset management and maintenance team to do whatever they like and create their schedule and create everything. Right now, we're at the stage of we don't wait till the end of the project. We bring them in as early as we can. We give them more information. We give them BIM models and we give them everything. But still, that is not enough. We still need to move towards more taking advantage of more information. And the next stage most likely would be the asset management team taking advantage of the BIM models and using it to create digital twins to manage the assets properly. And assets in this case covers both the buildings, the machines, the pipelines, and whatever the client considers to be important for maintenance. So the project objectives are divided into 5, basically summarized into 5. The first step is to define the information requirements according to ISO, and the information requirements that are specific to asset management are the OIR, AIR, and EIR. These documents are important to asset management. And also to develop the level of information need. But in this case, the level of information need is very specific because it's tailored to meeting the needs of the asset management team. And also create a BIM model, which is just for the case study for this project. And also make use of COBie to accurately map the data from COBie into the asset management software, which in this case, for this case study, it was IBM Maximo. And at the end of the day, we also wanted to have the BIM viewer within the asset management software environment using Autodesk Forge. So the thesis workflow is basically, we analyzed existing information from the client. They had existing information in form of CAD drawings, and they have schedules, they have the current asset management processes, they have their naming conventions, IDs, and the way they maintain their documents. We analyze this information and we use this information to develop the level of information need. And finally, the information defined in the level of information need was used to develop the BIM model along with all the information right inside Revit. Then finally, export COBie data, update COBie data, import COBie data into IBM Maximo, which is the asset management software, and also import the BIM model using the Autodesk Forge plugin into IBM Maximo, then test the functionality and use them to create work orders, and just at the end of the day, evaluate how successful it is, how useful it is to the asset management team. So the first step is defining the information requirement for the maintenance team. This process was a little bit tasking because it's different when you are defining information requirements for construction. But for asset management, you need to ask a lot of questions because they are not so familiar with the rules and with the words we use in the construction industry. So I had to ask the maintenance team about their goals and objectives. And for example, we can see one of their objectives was to reduce corrective maintenance through visualization. And for each of the goals they defined, we attached information requirements to the goals. And finally, standards that would be implemented to achieve these goals. For the AIR basically just defined the scope of the asset information that they want to keep. Because, for example, for the clients in this case, they place more emphasis and more importance on their equipment and their pipes and everything. They care less about the walls or the columns. So it's very important, but we kept less information on these assets in this regard. Then for the exchange information requirements, we had to specify the mode and also the data types we want for our information. And in this case, we specified for not just for, when the asset management team wanted to keep some information for themselves, so they want to be able to specify to, at the end of the day, any appointed party, so that the appointed party would know exactly the delivery format and what to give the asset management team. For the level of information need, this was briefly defined, like structured into geometric and non-geometric information. And for the geometric, and we know we looked at things that had to do with geometric behavior, parametric behavior, appearance, and things like that. Then for the non-geometric information, we classified it into two, the alphanumerical information and the documentation. Briefly, to the left is the structure we use to divide the level of information need. So for the architectural and hydraulics and other systems. So for the architectural, we splitted it into architectural elements and architectural equipment. And for the hydraulics, we have hydraulics network and hydraulics equipment. This is because the level of information need for assets in these groups are very different. So we divided them in this manner. For the hydraulic networks, we have the pipes and the likes. For the equipment, we have the machines, the oil separators, and things like that. So we spent time developing the level of information need because it is very important. It provides the method for describing the information and also leads to what we call time saving. So we don't spend a lot of time sorting out information relevant to the asset management team. And also it helps us in creating information in a structured form. For the geometric level of information, briefly, this is an example. We did this for all the other systems. This is for architectural and structural elements. They were grouped in the same, they were all in the same group. We defined them in simple English words that can be interpreted by an appointed party at the end of the day. So in this group, we have the columns and the doors and walls and roofs. Basically, the static parts of the building, we defined their geometric level of information in this format. Then for the non-geometric level of information need, for this part, we spent some time creating property data templates, which is very important to the asset management team. And this is just a template that has the property sets that the maintenance team are going to use. Because at the end of the day, when we create BIM models in construction, we have a large amount of property lists and some window sizes and sizes of ledge and things like that. This information, most of the time, is irrelevant to the maintenance team. They just want specific information on specific assets. So this template was created to guide the appointed party so that they know exactly what is required by operations and maintenance, and they prepare the BIM model to match these property sets. And finally, from the property sets template, which is like an Excel sheet, we move them into a shared parameter file because we used Revit, and this was done so that it can be used for some other projects and the appointed party can have an idea of exactly the properties which should be the project properties within the BIM authoring environment. And finally, the properties will find themselves on the spreadsheet on COBie, which is the attribute spreadsheet, which I'll be showing very soon. But one thing to note is that this information was gathered systematically based on the frequency of use of the equipment or assets, the type of building element or equipment, like what group it belongs to. Is it for HVAC? Is it for hydraulics? Is it for the refrigerating system? And what is its relevant to the operations and maintenance team? In this case, I had to carry out simple interviews, asking the maintenance guys, how often do you use this? How often do you change this? Do you want to keep information on the heights and things like that? For the modeling aspect, basically we followed the information that we defined in the level of information need, and we created a model for architectural, structural, and hydraulics, basically because we wanted to spend more time defining the information and structure. So we just did for just the systems, it was developed as shown. For the COBie, briefly, I will just try to explain the COBie structure. COBie is simple. It is spreadsheets, and on each sheet, we have information that have been investigated to be relevant to operations and maintenance, and every information is all linked. We have sheets that are required. That is, they are very important. They have to be filled. And we have other sheets that are not so important, but you can fill them up if they are important to your operations and maintenance. So basically, the important sheets are the contacts, which is just the person creating the spreadsheet, or those you feel they are the key people in the maintenance team. Their names and their information can be on the contact. And also the floor, the facility, the space, and components, which is all the assets, then attributes. These are very important. Then for the COBie worksheets, they were translated to Maximo, which is the asset management software. The company information is in the contact. The facility is also like a location hierarchy, which I would explain in the next slide. Then the floor is also a location hierarchy, the space, and so on. So basically, let me briefly explain the assets location hierarchy. For asset management, they classify assets in a particular way. It's different for every organization and every company. They have their way of classifying assets. And this is different for construction. We don't really do that. We have our classification, which is omni-class or uni-class, or as you like it. But for asset managers, they like to classify assets based on sometimes the use or the location and things like that. And sometimes they use both information to classify. So on the right, we have the current hierarchy, which is used. They have a multi-step hierarchy, which can be classified according to the use and space. But in COBie, we are limited to just 4 layers because of these 4 spreadsheets that are important, which is the facility, the floor, the spaces, then the asset itself. And this is one of the limits with working with COBie and importing directly into the asset management software. For the geometric information, we used Autodesk Forge, and Autodesk Forge was installed. And after that, we created the storage bucket, which is an housing unit for all the models. It's just a place, a pocket where we can store models, multiple models, and multiple files in all kinds of formats. And finally, it was installed in Maximo after a lot of effort by the maintenance team, because the truth is you require access the asset management database to install such plugins. So briefly, the improvement in information management between these two processes. So after implementing ISO and implementing the technology that comes with ISO, which is making use of the COBie file and making use of your model within asset management, we can see some improvement and some changes. One is that when you want to update information in the old process, you can either log into Maximo and update asset information manually, or you can use the spreadsheet, update it on the spreadsheet, then kind of run a script to load it into Maximo. Then you have to go back into the software to check if everything is as it should be. But with COBE, it is easier if the steps that we defined are followed, because the COBE is defined according to the asset team's requirements. So all you need to do is upload the COBE file and they go into the right tables. And in case you have large form of assets, maybe you are expanding and you are buying new assets, you are changing things, you don't need to delete. All you need to do is update, and it automatically recognizes the existing information that was imported and just changes it. And this is one of the benefits of using this method. It saves a lot of time and it creates structure. And one of the things that is very important that comes with the to-be process is also geometric information. In the old process, there was nothing of no geometric information. You just create all your information based on textual data and schedules. But now the geometric information can be added to work orders and things like that. So briefly, the conclusion. So one of the important conclusions that I would like to mention and like to say is some of the long-term benefits of having BIM in asset management, which is considerable time saving in fault finding and keeping equipment information. Because one thing the maintenance team mentioned to me is that they spend a lot of time searching for equipment information, and also cost savings by making informed procurement and repair. The truth is, when you keep more information and relevant information, you can make informed procurement. You can keep the names of certain manufacturers if they've been good in the past, or you can decide to repair when necessary or not to repair. And also it improves the overall information management system because you know exactly where each information is, and total operational excellence. For the future development, I'll just briefly touch on two areas. Under the two areas, there are a lot to do in those regards. For the information technology area, which is IT, we need to work on improving open formats for asset management software. That is COBE and IFC, and there are more, but for now, I think the only ones adaptable to the asset management softwares for now is COBE and IFC. They need to be more usable and more adaptable because the people in this industry, they are not so familiar with these open formats, and also cultural change and improved technology, improved knowledge in BIM. This is going to take a while because it has to do with process and changes. The asset management industry, they have their own standards and have their own processes, and which is very different from what we have in the construction industry. So there has to be more synergy and more knowledge. And even in the asset management team, there has to be people and staff members with knowledge of BIM. Thank you.